So now that we have explored our parent functions, we are going to figure out how to move them. So there's something called shifting graphs. Shifting is called it's like moving up, down, left, right, any direction. We're not multiplying or doing anything like that yet. It's just going to move up, down, left, or right. So the location changes, but the shape does not change. So that's where remembering your parent functions is super important. I'm going to show you guys how I start with the parent function every single time, and then I come up with my graph from there. So with this one, graph each function, state the domain and range. So the first thing I notice is that I have an x squared. So I have an x squared, so that makes me think of my parabolic or my quadratic parent function. My quadratic parent function looked something like that. If it helps you, kind of draw in what your quadratic parent function looked like. It was something like that, right? So now, this plus 3, there's two places that numbers can be. They can be with the x or not. So the way that that looks, so like if I have something with my x, this is the way it would look. If it's not, it's like this. Let me take you through Desmos real quick, and I'll show you how this works. Desmos. And lucky you guys, you have a graphing calculator that you can check all these with. But if you're going into pre-AP, pre-cal, or anything like that, you better know how to graph this stuff. All right, so there is my regular parent function. So if I have x plus 2, I said x plus 3, raised to the second, what's going to happen is it actually takes that function and it moves it to the left 3. Kind of weird, right? Because we see a plus 3, right? So what I think of when I'm with my x's, I do the opposite of what I see. If you've ever dated anybody and you broke up with them, right? Aren't they called your ex? And usually it's kind of awkward, and you don't really want to be around them. So I mean, every now and then it's not, so it's fun, it's whatever. But if you have an ex that you kind of want to stay away from, right? Because it's just kind of awkward and whatever. Then you go the opposite direction is what you think. So when you're with your exes, go the opposite direction. So I had a plus 3 with my x, so I went the opposite direction. I actually moved in the negative direction. So now the other thing that could happen, like I said, is it could be outside of the parentheses. If it's outside, it's going to move it up and down. So I consider it to be with the y. So here's where I do exactly what I see. So if I see a plus 3, I move it up 3. If I see a minus 3, then I move it down 3. Right? So with our y's, we move it up or we move it down. With our x's, we move it left or we move it to the right. Again, do the exact opposite as what you see. All right, so knowing all that, let's graph some stuff. Let's graph. All right, so now, we kind of cheated and we already know this one now. So this plus 3 is not with my x, so it's going to move it in the y direction. So I'm going to take all of my points, move them up 1, 2, 3, up 1, 2, 3, up 3, up 3, and up 3. If you also want, if you figure out kind of where your main point is, to me for the quadratic, it's the origin. Once you figure out where it goes up 3, you can go over 1, up 1, over 2, up 4, just like our parent function does. So now we will graph that, and this is our actual function. That one in the dotted line, that's our parent function, so that just helps us to graph it. You don't always have to like put it on there, but the one that we're going to be looking for is the one in pink right there. All right, so now for the domain and range, for the domain, it's still going left and right forever, so negative infinity to infinity. And the range, the lowest y value we have is 3 right there, and it's going from 3 up forever, so 3 to infinity. All right, moving on. So I have a cubic. Notice I have a cubic, right? So I have a cubic, which is something like this. I put my parent points on there, and it's something like that. Cubic parent function. And it is moving down 4. That minus 4 is not with the x, so that will move it down 4. So I move everything down 4. That one's going to move off my graph down there. And if I move that down 4, it's right there. So now I have a graph something like that. That's it. That's all there is to it. It's the domain and the range. So the domain's going left and right forever, so negative infinity to infinity. The range is also going up and down forever, so that is also negative infinity to infinity. All right, moving on. So notice here, I see an absolute value symbol, so that makes me think of my absolute value parent graph, which is like that weird V-looking one. Sorry, I turned my paper sideways, it's hard to draw it that direction. So notice, this is inside with the x. If it were outside the absolute value, it would be something like that. But it's not, it's inside, it's with the x. So since it's right next to the x, it's going to move it in the x direction, and I do it the opposite of what I see. So this is actually going to move it to the right 3 units. So I take it 1, 2, 3 units to the right, and I draw my new function. So it would be something like that in pink. That would be to the right 3. So now for the domain, still going left and right forever, so negative infinity to infinity. And for the range, the lowest y value is 0, and then it goes up in both directions forever and ever, so 0 to infinity. Notice that 0 is included again with that bracket. All right, the next one I see is a reciprocal. It's a reciprocal because it's 1 over an x. It's the x's in the denominator. So when I think of reciprocal, this is another weirdo, but he gets closer to those asymptotes, right? So it's kind of hard to see, but it's in black there. It's yeah, you guys can see that. So it's kind of like curving right here. And then it curves right here. It's getting closer to the asymptotes as it goes in both directions. So now this plus 2 is also with my x. It's in the denominator right next to the x. So what that does is it moves everything to the left 2 units. I know that I had asymptotes here and I had an asymptote here. So what I like to do is I like to just move my asymptotes. So since this vertical asymptote is moving to the left 2, I'm going to draw a new vertical asymptote right at negative 2 because I know I'm getting closer and closer to that as I go. Now it did not move up or down, so the horizontal is going to stay exactly where it is. I have a point here and a point there, and then I'm going to get closer to the asymptotes as I go out in both directions. So closer and closer, closer and closer, and there would be our new reciprocal function. Now for the domain and range. So for our domain, it's going left and right forever, except for this value at negative 2, right? We cannot divide by 0, so negative 2, if x were negative 2, I would be dividing by 0, but that's not possible. So I'm going everywhere from negative infinity to negative 2, or from negative 2 to infinity. My domain is in either of those intervals. All right, now for the range, I'm going up and down forever, except for y cannot be 0 in this case. So I have negative infinity to 0, or 0 to infinity, just like my parent function. All right, moving on. So here, notice I have a bunch more junk. So this one, we can do multiple things. We can do as many things as we want in an equation. So this one, I have something inside with the x. I also have something outside, so it's going to move in the y direction. I also notice that it has a squared, so that tells me what parent function I have. Since I have a squared, what that means for me is that I have a quadratic parent function. So that's why I started graphing the quadratic parent function. All right, so there's my quadratic parent function, kind of ugly on that left side, but it's aight. All right, so this plus 3 right here, remember do the opposite with your x. So this is going to move it to the left 3 units. This minus 5 on the outside is going to move everything down 5. So I have left 1, 2, 3, down 1, 2, 3, 4, 5. Get that in the right spot. So I have, there's my graph. Left 3, down 5, 1, 2, and 4, 4, and I have my new parabola looking like so. Oh, it's so pretty. Actually, it's not very pretty. That left side should be going out more. Oh well. So for the domain, going left and right forever, so still negative infinity to infinity. For the range, the lowest y value I can possibly have is this negative 5 right there. So I have everything from negative 5 and it's going up forever to infinity. There would be our range. All right, we got a few more for you guys. Looks like we got 3 more. We're so close. Now we only have 1 more section in this unit. Crazy. It's going so fast. All right, so I notice I have a reciprocal function because the x is in the denominator. So I think of my reciprocal parent function, which looks something like so. So now this plus 3, do the opposite with your x. And then the plus 2, do the same with your y, so we'll move it up 2. So we'll move into the right 3 and up 2. So I'm going to take those asymptotes. The first one was my vertical asymptote at 0, so now it's going to be at 3. And then the other asymptote I had was my horizontal asymptote. So instead of being at y equals 0, it's going to be at y equals 2 since it moved up 2 now. So now I can graph my points where they should be, right inside those asymptotes, yeah. And then get closer to your asymptotes as you go out in both directions forever and ever. Forever? Forever, ever? Right. So then for our domain is all of our x values except the ones that we cannot have, so negative infinity to 3 and 3 to infinity. All right, the range is all the y values except for what we can't have, which would be 2. It's not at 2 because there's an asymptote there. So negative infinity to 2 or 2 to infinity. Right, there's our domain and range. Well, last one, we got our cube root parent function. So I know my cube root parent function had some points out here because it's the inverse of my cubic function. So I have something going like that. Now this plus 5, I'm going to do the opposite and move it left 5. This plus 1 on the outside is going to move my graph up 1. So when I move it left 1, 2, 3, 4, 5, up 1, I have my new graph. Let's see, 5, up 1, so that should be there. So I'd be looking something like that. So now the domain, the range, it's going left and right forever, so negative infinity to infinity. It's going up and down forever, so also negative infinity to infinity. All right, last one here. So it says, given f of x equals negative x squared is shown. So it's kind of giving you a new parent function. This is our f of x right there. What equation represents g of x? So it looks like, here's a 1 right there, there's 2 right there. So it looks like I just took my graph of negative x squared and moved it up 2. So all you're going to say for questions like this is g of x equals, take your function that they give you, so negative x squared. Since it moved up 2, that's going to go on the outside, so plus 2 will move it up 2. All right, hopefully this video was helpful for you guys. Super cheerful, excited monkey for you guys. Doing Algebra 2? Yeah, almost done with the first semester. All right, keep up the good work. Let me know what I can do to help you guys out. I'll talk to you all soon.